In this project, we will learn about servos and how they work. They are a very common component in electronics projects. We will learn how to connect them in a circuit and control them with your Arduino. Our pan tilt assembly control will actually use two servos to control the pan and tilt motion, so it's important we understand how they work. Let's take a look at the objectives. By successfully completing this project, we will have mastered the following items. You will understand what servos are and how they operate. You will understand how to connect a servo in a circuit, and you will also understand how to control the position of a servo in code by using the servo library. If you are ready to begin, let's get this project started. Here are the parts we will need: an Arduino Uno, a USB cable, a breadboard, two mini servos, and connecting wires. So, what are servos? These components are used in industrial applications, robotics, inline manufacturing, and in remote-controlled or radio-controlled toy cars, robots, and airplanes. To fully understand how a servo works, you have to look under the hood. They consist of a very simple setup: a small DC motor, a potentiometer, and a control circuit. The motor is attached by gears to the control wheel. As the motor rotates, the potentiometer's resistance changes, so the control circuit can precisely regulate how much movement there is and in what direction. Servos are controlled by sending pulse-width modulated signals, or PWM signals, through the control wire. A servo motor can usually turn 90 degrees in either direction for a total of 180 degrees total movement. The width of the pulse determines the direction the servo will move. A 1.5 millisecond pulse will turn the servo to a 90-degree position or center. Shorter than 1.5 milliseconds moves the servo to 0 degrees, and greater than 1.5 milliseconds will turn the servo to 180 degrees. There is a library in Arduino which abstracts all of this away from us and easily lets us control a servo direction. We will take a look at this when we examine the code. Let's take a look at the circuit diagram for a single servo circuit. So the servo has three connecting wires. One of the wires is connected to the ground pin on the Arduino. The other wire is connected to the 5 volts pin on the Arduino, and for our circuit, the signal wire will be connected to pin 9 on the Arduino. That completes our wiring. Now we're going to wire up our single servo circuit. So as you can see, this is our micro servo, and I'm going to attach a servo horn at the top of the servo. Those are attachments that you would get with the servo, so I'm going to put on a servo horn so that we'll be able to see the direction that the servo is spinning in. As you'll notice, the servo has 3 wires that are coming out of it, and this micro servo that I have ends in a female connector. So for the color codes here, the orange wire is the signal wire, the red is the positive that's connected to 5 volts on your Arduino, and the brown is the ground wire. So I'm just going to go ahead and put a couple of male pins here to make things a little easier to connect to our Arduino. So this would be our signal wire. This is going to be our 5 volts wire, and then we're going to have our ground wire. So to wire that up to the Arduino, alright, so this particular wire here is ground, so I'm going to connect that to ground. The second one here is 5 volts, so that's going to go to 5 volts. And finally, the signal wire is going to go to pin 9 on our Arduino. Alright, so I'm not going to use a breadboard in this one, just going to directly connect it to the Arduino, and we will take a look at this and upload the code. Now I'll go ahead and upload the code for our single servo circuit, and I'll be using the sweep demo code. To get to that, you can click on File, Examples in the Arduino IDE, and if you go down to Servo, you'll see that sweep demo program. So go ahead and click on that. When it opens up, I'll go ahead and upload that code now. Alright, so here it goes. So this program is very straightforward. It simply sweeps between 0 and 180 degrees for our servo. So as you can see with the servo horn that's attached, we're able to see the motion of the servo. So there you have it. Let's dive into the code for our single servo sweep program. So initially at the beginning we include the servo library, and we create the servo object that we're going to use to control the servo. So we just do a servo and we call that object myServo. There's a global variable that we use to store the servo position, so it's an integer, int position equals 0, and that's the only global variable we'll need. Next, in our setup, we would want to attach the particular pin to associate that signal pin with our servo. So we do a myServo.attach, and we pass in 9. Remember, the signal pin is connected to pin 9 on our circuit. In the loop function, we do a loop between 0 and 180 initially, incrementing every time by 1 degree. And to write that to the servo, we do a myServo.write the position. So it starts at 0, then it goes to 1, 2, 3, all the way up to 180 with a small 15 millisecond delay in between each write. And when we do, of course, do a write, that's when the servo would move. So the servo initially incrementally moves between 0 and all the way to 180. And then when it reaches the end, we loop back from 180 to 0, decrementing this time. So that would be 180 degrees first, then we would go to 179, 178, and so forth, all the way down to 0. And for each iteration of our loop, we do a myServo.write the position, and we have a small delay. So essentially, this causes the servo to start at 0, it goes all the way up to 180, and then it comes back from 180 all the way back down to 0. So that is our sweeping motion. Very simple and straightforward program, and it illustrates how we can get a servo to sweep completely from 0 to 180 degrees and back. Now we will wire up our dual servo circuit. So as you can see, we have 2 servos that we're going to connect. So first I'll connect the ground on the Arduino to the ground rail on the breadboard. Then I'll connect the 5 volts. To the 5-volt rail. Here is our first servo. So again, for that servo, the brown wire is the ground wire. So that will be ground. The middle wire is going to be our orange, which is our 5 volts. And the first servo, the signal wire, goes to pin 9 on the Arduino. Alright, so that's that connection there. For our second servo, Again, the brown is going to be the ground wire. The middle one is going to be the 5 volts. And finally, the signal wire is going to be connected to pin 10 on the Arduino. So I'll make that connection. Alright, so that completes our wiring for both our servos. Now we'll go ahead and upload the code for our dual servo circuit. Just one thing to bear in mind is that because we're driving 2 servos, we need a little extra power to the Arduino. So I've attached here just a 9-volt battery with a barrel connector to the Arduino just to provide a little extra power since we're controlling 2 servos. And I'll go ahead and upload that code now. Alright, so here are the both servos. Alright, so there they go. So in this particular program, we're doing a sweep, but instead of just one servo, we're using 2 servos. So as you can see, both servos here are doing a sweep between 0 and 180 degrees. This is all leading up to our pan tilt assembly, as we'll need 2 servos, one for the panning motion and the other one for the tilting motion. So now that we have demonstrated how we can get 2 servos working together, we'll complete the assembly in the next project. Let's quickly take a look at the dual servo sweep program. So initially we include our servo library, and instead of setting up one servo object, we set up 2. So we have myServo1 and myServo2. Again, we have that global variable which we use to store the servo position. So we have, it's an integer position equals 0. In our setup function, we just do a double attach. So we attach pin 9 to the first servo object and pin 10 to the second servo object. Remember, that's where our signal pins from the servos were connected. In the loop function, again, we loop from 0 to 180, incrementing by 1 degree every time in our loop. And to cause that change in the servos, we do a servo.write, passing in that position. That causes each servo to start at 0, go all the way to 180, and then when we reach 180, we decrement back down to 0. So in this second for loop, we go from position equal to 180 down to position equal 0, decrementing each time in the iterations in the loop, and we do a myServo.write out the position, again with a small 15 millisecond delay. So this just doubles up on our previous program and causes both servos to start at 0, go all the way to 180, and then from 180 they go back down to 0 in a full sweep. To summarize, in this project, you were introduced to an important component which can be used in many of your electronics projects to result in motion, a servo. You learned how it operates, how to connect a servo in a circuit, and how to control it in code using the servo library. This is all leading up to our final section in this project where we put all the concepts together. Let's move on to our next lesson.